morning. How are you all doing? So today we have a double hitter. We have 2 lessons for the price of 1. We're going to do 7-5 and we're going to do 10-2. Well, what is 7-5? What is 10-2? Well, one of them is simplifying radical expressions. We're literally going to take this thing and break it down into its most simple ingredients. It's kind of like if you went to a restaurant and you're like, wow, this is amazing. I taste a little cinnamon. Ooh, I taste a little oregano. So it's kind of like breaking down a recipe into its baby ingredients. Or we're going to do that for math expressions. The second part is learning to rewrite expressions from one form called radical form to another form called rational form. So we're going to learn how to go back and forth between the 2 types and just learn how to rewrite them, okay? So double hitter, 7-5 and 10-2. So when you go to Canvas, everything's on there. Since it's a double hitter, you have 2 pages of notes and you have 2 pages of homework. So the double hitter notes are right here. So we have in-class notes, where we're learning to change these things called rational expressions into radical form. And then the bottom part, we're changing these exponential or rational expressions into radical form, okay? So pretty cool. And the other side, more in-class notes. And here we're simplifying radical expressions. So we're breaking this big thing down to its finest ingredients. Okay, cool. So let's get started on this side. So what you're looking at is called a radical. This symbol right here, you might know as a square root. We can also say radical, okay? Radical. A radical has something on the inside, some type of expression. It could be numbers, it could be letters, it could be both, combination. And we simplifying it by breaking it down using a factor tree and then looking for sets that we can take out. In our case, we're only looking for sets of 2. The reason is most radicals have an invisible 2 sitting right here that says, hey, anybody leaving this radical has to leave in sets of 2, okay? So I'm gonna make this a little bit closer so you guys can see. Nice, let's go a little bit closer. Cool. So we have this first question here. Let me bring it down ever so slightly, just so I know we can see it well. So we're gonna break the number 8 down into its finest ingredients. So let's do that. I'm gonna do 8 here, and we're gonna do a factor tree. A factor tree is something that you learned about in elementary school, probably 5th grade. So we're gonna break this down. Can you think of 2 numbers that multiply to give me 8? 2 and 4, correct. I'm gonna circle the number that can no longer be broken down because we consider it prime. Prime means it's only that number times 1 that makes that number. Which one of these 2 numbers can no longer be broken down? Right, it's 2. Because the only thing that makes 2 is 2 times 1. So we're going to continue breaking down 4. 2 times 2. Wow, we just learned that 8 can break down to be 2 times 2 times 2. Nicely done. I'm going to move this back ever so slightly. Cool, okay. So we know that we can break this down now into 3 2's. So I'm gonna rewrite the radical and rewrite this as 2 times 2 times 2. I haven't really changed the question. I know that 8 is the same thing as 2 times 2 times 2. And all of these are prime numbers. They can't be broken down further. Now I need to simplify. There's an invisible little 2 here. Sometimes there can be a 3 or a 4 or a 5 there, but they have to show themselves. They're not allowed to be invisible. But a 2 is allowed to be invisible. So if you don't see the little root, that's what that's called, the little root, you can put the 2. And if there's already a number there, you're going to see a number. This is saying, hey, welcome to my radical party, everybody. If you want to leave, you have to leave in sets of 2. That means you and your friend need to look exactly the same before you leave. So I can see these 2 are exactly the same. I see a set of 2 things, and they're going to leave this radical party, okay? I see one set of 2 just left. Does he have a partner to leave? Because you can only leave in sets of 2. No, he can't. So our final answer is going to be a 2 on the outside. That was that set that left, and a random little 2 on the inside that couldn't leave because he didn't have a partner. Now, do you need the little 2? That's up to you. You can put that little root if you'd like. Let's try the next, let's try 45 since we're sitting right here. 45, first thing I'm going to do is break it down to its finest ingredients. I know that 45 is 9 times 5. 5 is a prime number because the only thing that multiplies to give me 5 is 5 times 1. And 9 is 3 times 3, and those are prime numbers. So I know that 45 is the same thing as 3 times 3 times 5. Cool. So I'm going to rewrite this. 45, you are the same thing as saying 3 times 3 times 5. Let's try it out. 3 times 3 is 9, 9 times 5 is 45. Yeah, I just broke it down to its finest ingredients. And now, I don't see the root. The root is 2 then. I'm looking for sets of 2 to leave the radical party. So, when in doubt, we wrote it out. We look for a set. We bring it out. What'd she say again? When in doubt, we wrote it out. We look for a set. We bring it out. I see a set of 3s right here, so they get to leave. There's that little set of 3 that just left that radical party. Can he leave? Does he have a partner that looks just like him? That would be a nope. So we're going to write our final answer with a 3 on the outside and a 5 left on the inside. Now, who is that 3 on the outside? That's that set of 3s that left. And who's left on the inside? That single 5 that had nobody to pair up with, okay? So that is my final answer. And yeah, you can put the little root of 2 if you'd like. And that's my final answer there. Why don't you guys try 2, 4, 6, and 5 on your own? So your first step is you're going to break it down using a factor tree into its primes. You're going to rewrite it. You're going to grab sets of 2 to go outside, and anybody that's a singleton, a single piece, stays behind inside of the radical. So you're going to try 2, 4, 6, and 5. 2, 4, 6, 5. Okay? You guys give that a go. I'm going to erase and move this about. Okay? Awesome. Welcome back. I hope you gave this a try. So I'm going to try question 2, which is 80. So I'm going to break down 80 by a factor tree. 80 is 8 times 10. Miss Miller, I didn't think of it as 8 times 10. I thought of it as 20 times 4. The beauty is your factor tree and my factor tree will ultimately look the same because we're breaking it down into primes. We'll get there, same place, I promise. 8 is not a prime number because it can still be broken down. Well, what's the opposite of a prime number? It's called a composite. A composite can still be broken down, but we want primes. 2 times 4, which one of those can no longer be broken down? Good, yes, it's the 2. And then 4 can keep going and then, stop. Well, we still have this 10 that we need to break down, so break down the 10. We have 2 and 5. Cool. 80 is the same thing as 2 times 2 times 2 times 2 times 5. Now notice I circle the primes. Why? I'm a visual learner. Helps me catch my answers easier and quicker. So 2, 2, 2, 2, 5. 2, 2, 2, 2, 5. If you don't believe me, you can multiply that out, and you, in fact, will get 80. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 5 is 80. Now, we're looking for sets of 2. Sometimes we would be looking for sets of 3, but a little 3 would have to be there, okay? But we're looking for sets of 2 to leave the party. They get to leave. They get to leave. Uh-oh, I have 2 sets who left. You're going to multiply them on the outside. This dude doesn't get to leave. He's a singleton. That means he's all by himself, and we can only leave in sets of 2. So 2 times 2 on the outside is 4, which represents the 2 sets of 2 that we brought out, and we have our single 5. Final answer. I know this one because it's a perfect square. We have a lot of perfect squares that we should have memorized, like the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6, the square root of 49 is 7, the square root of 64 is 8. Do I still have more room? I do. The square root of 81 is 9. The square root of 100 is 10. And it goes on and on from there. 121, 144, 169, 196, 225, 256, 289. And it just keeps going on and on, right? So I do have a poster on my wall of the perfect squares, and you're also welcome to always reference it, okay? So I see that 64 is a perfect square. So I'm just going to go with 8 and call it a day. You're like, well, what the heck does that look like when you write it out? Well, it was like a sea of 2s. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2 is 64. One set, they leave. One set, they leave. One set, they leave. Everybody left. That means there was no radical in your final answer. Everybody left the radical party. Everyone's outside now. 2 times 2 times 2 is 8. That's why our final answer is just a single number with no radical left, because there were nobody left behind at the radical party. Cool. I'm going to end the video here, and then we're going to come back and do some more, okay? Good job. So this is 7.5/10.2, part 1. Good job.